This is the first part of the Raster Priority Lab assignment, which has a number of different objectives. The first objective is to familiarize you with the raster data structure. So you should have already downloaded and unzipped the raster priority dataset that I've provided for you. Open up ArcGIS, connect to the folder, and you will see that I've given you 3 files. The first one that I'm going to point your attention to is OCLU. This is a land use shapefile for Orange County, and based on its icon here in our catalog, we know already it's a file that we're familiar with, which is a vector polygon file. The other 2 files are grids. They are identified by this icon, which looks like a grid, a raster, a piece of graph paper. The first file is the digital elevation model for Laguna Beach, the Laguna Beach quadrangle digital elevation model, which is an actual grid file. And the other file is a digital raster graphic, the term DRG, which is a picture, which is a file that we can't do any math on, but we use as a reference underlying our data. So first let's bring in the DEM, and then I will bring in the TIFF. We have to do, it gives us a geographic coordinate system warning because the TIFF is not in the same coordinate system projection datum as the DEM. However, we can't project the TIFF because it's just colors, it's just pictures, and when you project it, it doesn't come out right. So just live with the fact that it's going to give you that transformation error and just project it on the fly. I'll start with the TIFF because the TIFF is a file that we can't really do any math on. It really just serves as a background, and it's familiar likely to many of you because it is an image of the raster, digital raster graphic or the quadrangle map that I've shown in class, and it's a typical USGS 1 to 24,000 7.5 minute quadrangle map, and it's the image of that, and you can explore that on your own a little bit and zoom in and around it, and you can see that it has the header information and all of that. So it's really just a scanned image. Can't do any typical grid analysis on it. However, this is the file that we're going to focus on, which is the Laguna Beach Digital Elevation Modeler, LAG-DEM. And this is a continuous data set. It comes in as stretched. Each cell is a float, and each cell in this grid has a value, and the elevation ranges between just below sea level, 0 to 361.26 meters. So the first step here is we're going to explore the properties of this grid. So it's ArcGIS, we right-click on everything and go to its properties. This is where we get a lot of information about our grid. So I want to call your attention to the basics of the properties that are very important. The first one is the columns and rows. That tells us how many columns and rows are in the grid. The next one is the cell size. That tells us that each cell is 9.4423137 meters by 9.442317 meters. So you multiply those by each other, and that's the area of each grid cell. Tells us what size this is. It's a floating point grid, and then you scroll down a little bit, and it has our coordinate system. So it's in WGS 84, UTM Zone 11 North, and additionally, it gives us general statistics for the grid. It tells us that the maximum elevation, the minimum elevation, and it also gives us the mean and standard deviation. The mean and standard deviation makes sense for grids that don't have a lot of zeros in them, but this grid has a lot of zeros in it because a lot of the elevation points are in the water. So just consider that these are just descriptive statistics. The information that I want to call your attention to mostly right now are columns and rows and the cell size. And I'm going to open up the Word document, and I'm going to have you record on your own this information in the properties. The first question is, what is the grid cell resolution? Do the math. That's the area of each grid cell. How many grid cells are in this DEM? Well, to figure out how many grid cells are in the DEM, you need to multiply the number of columns by the number of rows. Okay, so to figure out what the total area is that is covered by this quadrangle, you take the columns and rows and multiply the total number of columns and rows by the grid cell resolution. So the columns and rows, if you multiply 1265 times times 1498. That's how many grid cells you have in this entire quadrangle. That's a lot of grid cells. That's almost 2 million pieces of elevation data. 2 million, there's 1,894,970 raster grid cells. You multiply that by the grid cell resolution, and that gives you the total area in square meters. So times, and I'm going to round it up, 9.44 times 9.44, and that's the total area in square meters divided by 1,000 squared, which gives us 168.86 kilometers squared in this raster. That's the area. So that's the basics of the DEM, really general grid exploration, and we are going to do a lot more with the DEM in future labs, but I just am starting the process of getting you familiar with the DEM, acclimating you to its properties, understanding the difference between a raster grid and a TIFF, which is just an image. Can't do any math on the TIFF, it's just there for reference. And we are going to, in the next step, start doing some really basic analysis with the DEM.